All right. So we're going to be doing questions from the past question, and so doing question 1 to 5 in this video, and then in the next one I'll do 6 to 10. All right. So for question one now, we have that. So let me change the color of this ink to black. All right. So here we have the mean and variance of a geometric distribution is given by. So option A we have 1 over p. Option 1 over p comma q comma over q over p. Then B we have q over p comma q over p square. Then C we have p over q comma 1 over q, and D we have 1 over p comma 1 minus p over p square. So for a geometric distribution, the mean is given by q over p, and the variance is given by q over p square. This is for a geometric distribution. This could also ask you for binomial and Bernoulli. So if it's for Bernoulli, our mean is given by p, and the variance is given by pq. Now q is equal to 1 minus p. So they could write it anyhow, right? Alright, hold on. So here we have q is equals to 1 minus p. So they could also write this variance as v of x equals to p into bracket 1 minus p. This is the same thing as this. It means the same thing because q is equals to 1 minus p. Alright, then we have binomial. Binomial, to get the mean and variance of a binomial distribution, it is just n multiplied by Bernoulli's distribution. So if we are getting the mean of a binomial distribution now, the mean is going to be n times the Bernoulli zone, which is p. So np is the mean of a binomial distribution. So now the variance is going to be n times that of the Bernoulli zone, which is pq. So this is going to be npq, or np comma 1 minus p. So this is the variance of this. But for this question, they asked us for geometric distribution, and our answer is going to be option B. Option B. So let me quickly clear this. I'm coming. So yeah. Hey, I don't go clear past it as it was clear. Let me just. Alright, so now let's do question 2. Question 2 says we should calculate the correlation coefficient of 7 collected data. Right, 7 collected data. Alright, so now I don't think this will come out in our test, right, because the lecturer did not touch it, but still, let us just look at it. So now calculate the correlation coefficient of 7 collected data. So when you're looking for correlation coefficients, the formula is fxy is equal to n summation xy minus summation x multiplied by summation y all over the square root of, you open your brackets, you have n summation x squared minus summation x squared, close your bracket, open another one, so you put your n, then you have summation y squared minus summation y squared. Alright, so I know this formula looks long, but once you know this formula, you'll be able to solve this question, right? You'll be able to solve this question effectively. Alright, so now the way the question could come is that they give you a table, but this one they already gave us these values. Now if they give you a table, there will be a table of 2 values there. The first one will be your x values, and the second one will be your y values. It might not be the first one might not be the x, the second one might be the x values. Sometimes they will not tell you which one is x, but the smaller one is always the x and the bigger one is the y, right? And then so when they give you just these 2 values, what you will now do is do another table. You put x square, you do another table, you put y square, and you do another table where you put x y. right? So once you put all these things, then you now put your values for x and y will be given, right? So then you do one the x square. Let's say it's 1 that is here, you do 1 square, you get your value for here. Let's say it's 2 that is here, you do 2 square, you get your value for here. Then you do 1 times 2 to get xy to be 2. So you do like after you are done with everything, you now calculate everything for x. You get the answer, you add everything together. Say it's 1 2 3, 1 plus 2 plus 3 6. Let's say 2 4 5, 4 plus 5 plus 2 11. So these values now, this one that is here is called summation x, because you are adding all the x values. So you are summing all the x values. Then this one that is here is summation y. This one that is here is summation x square. Then this one that is here is your summation y square. And then this last one is going to be your summation x y. Right? Once you have all these values, then you'll be able to solve. Because if you look at the formula, you have summation x y. So once you have this value, you need your summation x, summation y, summation x square, summation x, summation y square, and summation y. Right? Once you get all these values, now the only thing that is left is your n. Right? So now for this question, they told us that calculate the correlation coefficient of 7 collected data. So they're telling us that n is 7. That's what it means. So we'll just write it here. N is equal to 7. So now for this kind of question where they will give you table, they might not give you this thing, right? They will just put something like this. They just put something like, they can put anything here. Let's say months. We'll put months. Then here they can put January, February, March, April, and they can stop here. So once they stop here, you just count 1 2 3 4. Your n is going to be 4. It is that simple, right? So n is equals to 7. Then summation ey at the summation xy is 172 here. So we just write summation xy equals to 172. Then we have summation x to be equal to 32. Then we have summation y equals to 28. Then we have summation x square equal to 210. And then we have summation y square to be equal to 146. Now in the question that is in that PDF, this summation y was not given, it was omitted, and without it you cannot solve the question. But I've been able to like try and get what this y value was supposed to be, what they omitted. So I was able to get it to be 28. So now that we have all these values, we can start solving our question. So let me just clean this so that we can solve. Okay, that was too much. I don't know, it's not undoing. That's fine, no problem. So let me just clean, let me write it again so it will be clearer. Right. Let me reduce the thickness of the pen. Alright, so here, when you are looking for the correlation value, you can also represent with r instead of that x. So r is equal to n multiplied by summation xy minus summation x multiplied by summation y, everything over square root. Then you open a bracket, you put summation x square. Okay, so there's n here, you put n multiplied by summation x square minus summation x all squared. You close your bracket, you open another one. This one is going to carry the y values. Summation y square minus, open a bracket, summation y square. Just try this formula before you go for your exam. I'm like 60% sure that this will not come out, yeah. But if they want to be wicked, then we'll see it in our exam. But if you see it, you'll be able to solve them now. Alright, let's go. So we said n is equal to 7. Summation xy is equal to 172. Summation x is equal to 32. Summation y is equal to 28. Summation x squared equals to 210. Summation y squared equals to 146. So let's apply our formula and solve. So r, which is our correlation coefficient, is equal to n, which is 7, times summation xy, which is 172, minus summation x, which is 32, multiply by summation y, which is 28, all over, we have our square root, then we have n times summation x square, which is 210, minus summation x, then the square of that summation. This is summation x here. There's a difference, don't mistake it. This one is summation x square, but this one is summation x. But for here we have summation x. So what you are squaring here is summation x. You are not going to use summation x square. You are squaring summation x, and this is summation x 32. So you are squaring 32 square. You can put it in bracket like this, then close this bracket. Then you have the y values, but you put your n first. 7. We are following this formula. 7. Then you have summation y square. Summation y square is 146. Close your bracket, minus summation y squared, so 28. Then you close your bracket. All right. So r is going to be equal to. So I'm going to calculate the upper values. So we have 7 multiplied by 172 minus 32 times 28, and this gives us 308. So I'm going to write it here, 308. Then for the values at the bottom, you just use your calculator to be faster, to avoid errors. 7 times 210 minus 32 square. Alright, then you open another bracket, so you have 7 times 146 minus 28 squared. So this, okay, I think I've made a mistake. I'm trying to see where I did the mistake. Okay. Alright, so yes, I have 325.8. So now I'm going to use my calculator. So 308 divided by 325.8, and this gives me 0.94536. Alright, so the closest answer here is going to be option A. But now the thing is that just get the idea of this. Remember that I formulated this y value, right? I formulated this y value, so that's why maybe it's not accurate, because they did not give us an equation. It was missing, right? It's supposed to be there, right? If you check the PDF, you see that the y value summation y is not there, so I formulated it. But this is basically how you solve a correlation question. But question 3 is complete. So yes, when we solve, we should see our answer in the option. So I'm going to be solving question 3 now. So this is basically how you get the correlation coefficient of a set of data. So let me just erase this. You can pause the video to write. Let me erase this so that we can continue. Alright, so let's do question 3. So remember our formula. Our formula is correlation coefficient is equal to summation xy. We have n multiplied by summation xy minus summation x multiplied by summation y, everything all over. The moment you use a formula very well, use it that much. So if you can just try and solve the question about like 5 times, the formula will master you. So you have n summation x square minus summation x square, you close your bracket, you open another one, n summation y square minus summation y square, you close your bracket, right? So you have this, right? So now from the question, our summation xy is equal to 317, our summation x is equal to 29, our summation y is equal to 40, our summation x squared is equal to 243, summation y squared is equal to 418. So now let's find our correlation coefficients. So r is equal to n. Our n is, this one is for 5 collected data, right? 5 collected, so our n is equal to 5. So let's solve. So if we have 5 times summation xy, which is 317, minus summation x, which is 29, times summation y, which is 40. We have everything all over. We draw our roots. Then we have n, we open our brackets first. So we have 5 times summation x squared, which is 243, minus summation x squared, which is 29 squared. We close our bracket, then you open another one. So we have n multiplied by summation y squared, which is 418, minus summation y squared. So we have 40 square. You close your bracket. So now let's do this. So we have r is equal to, let me punch my calculator. So we have 5 times 317 minus 29 times 40. 29 times 4, that gives us 425. 425. Everything over. I'm going to do it. We have 5 times 243 minus 29 squared. 29 squared. Close your bracket, you open another one. So you have 5 times 418 minus 40 squared. You close your bracket. So what I have at the bottom is 428.088758, and this is going to be equal to, I'm coming. Alright, so I have 425 divided by 428.088758, and this gives me 0.9927. So that's option 0.9928, sorry. Remember, that's option A, because if you check the PDF, Jerry, the question 2 and question 3, they have the same option. So I know it's cancelled out here, but they have the same option. So yes, option A is correct for question 3, right? It's correct for question 3. So that's the answer, 0.99278. And with that, you'll be able to calculate the correlation coefficient. Now, this video is getting too long. I will do question 4 and question 5 in another